Hello students, in the last video I discussed about section A and section B of the ISC 2024 paper. In this video I am taking up section C of ISC 2024 paper. Let's see. Question number 12, it starts with question 12, 3 marks question each. For a reaction A plus B gives product, following data is obtained. We have the table of data here. Calculate the following. The first one is the overall order of the reaction. For this, we have to assume a rate equation. Let us take a rate is equal to K into concentration of A to the power P and concentration of B to the power Q. So P and Q alphabets we put. We need to find the values of this. So for this, let us take the equation. Maybe we can take the first one. That is 9.6 into 10 to the power minus 2. So that is rate is equal to the rate is given here. It is taken K into, so we have the rate is equal to what we have, concentration. What are the values here? 0.15 to the power P into 0.15 to the power Q. So we can take it as equation 1, and then second one we can take the next one, that is 3.84 into 10 to the power minus 1 is equal to we have the value 0.30 to the power P into 0.15 to the power Q, equation 2. So we need to solve and find out the value of P and Q from these equations. Okay, first let us see this. What you can do is maybe you can divide equation 2 by 1. So in that case, what you will get if you divide 2 by 1, that is 3.84 into 10 to the power minus 2 divided by 9.6 into 10 to the power minus 2, that's equal to 0.30 to the power P into 0.15 to the power Q divided by 0.15 to the power P into 0.15 to the power Q. So out of this, what you get from there, you get on solving this will cancel. So this is 10 to the power 1. Okay, it's equal to 4. This will become 4. It's equal to, out of this, these two will get cancelled. So you have 2 to the power P. This becomes 2 to the power P. So what you have, P is equal to square root of 4, that is equal to 2. So P is equal to 2. Now you can take the another equation here, any one of these equations, substitute the value of P there. I'll take the next one. Here we have 1.92 into 10 to the power minus 1 is equal to 0.15 to the power P into 0.30 to the power Q. So using this, now we can, this is taken as equation 3. I'll divide equation 3 by 1. Okay, so that is equation 1 was 3 is 1.92. Yeah, 1.92 into 10 to the power minus 1 is equal to 0.15 to the power P into 0.30 to the power Q, and divide that previous equation is taken, that is 9.6 into 10 to the power minus 2 is equal to 0.15 to the power P into 0.15 to the power Q. So solving this, we get 0.2 into 10 is equal to 2 to the power Q. So from here Q is equal to solve it, that is 2, yes, 2 to the power 1. So Q is equal to 1. So what do you get from here? We have already calculated P is equal to 2 and Q is equal to 1. So what is the overall order of the reaction? overall order is equal to 2 plus 1, P plus Q is equal to 3. So this is the first answer. So you can check how we solved it. We have taken both the equations from the table, solved mathematically, and got the value of P here. Then we got value of Q here, and then we added P plus Q, that is the overall order of the reaction. Now what will be the rate law equation? So the rate equation, rate is equal to K into concentration of A to the power P is 2 into concentration of B to the power Q is 1. So this is the rate equation. Now the third part is the value of the rate constant. Rate constant, applying the same equation, what you can take, rate is equal to K into A to the power 2 into B, concentration of B to the power 1. So substituting the values, any one of these values, maybe we'll take the first one, 9.6. So that is rate 9.6 into 10 to the power minus 2 is equal to K into concentration of 0.15 to the power 2 into 0.15 to the power 1. So from here K is equal to, we can calculate 9.6 into 10 to the power minus 2 divided by 0.15 to the power 3, 2 and 1, okay, multiply. So that's equal to, solving this using the calculator, we'll take up the values. It's coming 24.44 mole to the power minus 2 liter square and per second, using on the quantities a third order reaction, right? So this is solved. I hope you understood this. Going to the next question, question number 13. Here we have illustrated the following reactions by suitable examples. Number 1 is a coupling reaction. How do we explain coupling reaction? So we can take any one example. So maybe we can take benzene diazonium chloride reacting with phenol in alkaline medium, benzene diazonium chloride, benzene diazonium chloride N2Cl plus you can take phenol OH, and this hydrogen will take out, so HCl will be eliminated. Okay, so we take in alkaline medium, what do you have? The product will be N double bond N, and so this side will be OH. So P hydroxyazobenzene, so this will be a coupling reaction, plus HCl, the HCl is eliminated. So this is an example for coupling reaction. The next one is they are asking for acetylation of ethylamine. Acetylation of ethylamine. So can take ethylamine. Ethylamine is C2H5 NH2. Now it is a Lewis acid, the base Lewis base, and forms salt with the Lewis acid. So that concept can be applied on this. So acetylation, how we can do acetylation on this? So we can take CH3, acetyl chloride is taken, that is for acetylation. Pyridine, the medium, a neutral medium of pyridine is required, heat is required. So what you will get, C2H5 N C double bond O CH3, okay, and in this, yeah, one hydrogen will be there, one of the hydrogen is replaced, so hydrogen. So this is the product, N-ethyl acetamide. N-ethyl acetamide is produced, and what is eliminated? One hydrogen and chlorine, so HCl is eliminated. Okay, So this is acetylation of ethylamine. And next is aniline does not give Friedel-Crafts reaction. Give a reason. What is happening to aniline? So aniline is a Lewis base. This is what I was telling, Lewis base. And reacts with Lewis acid, AlCl3, to form coordinate bond. And hence what happens is AlCl3 is not available for formation of the electrophile. Okay, so this is the reaction, because the reaction between Lewis acid and base giving the salt, and coordinate bond is formed. No? Therefore, electrophile cannot be formed from AlCl3. So the Friedel-Crafts reaction does not take place. Going to the next part. Now question number 14. The next question here. Here this is an understanding question. Aradhana visits a physician as she is suffering from rickets and joint pain. Which fat soluble vitamin should the physician prescribe her? So this is the question that is asked. Okay, so we can understand Aradhana, just a case they are given just an example. So for any person suffering from rickets and joint pain, which vitamin? So it is vitamin D. Vitamin D should be prescribed. And the next part is Somesh put a few drops of vinegar in milk. What change do you think he observed in the milk after some time? Okay, vinegar is acetic acid added to milk. What is this phenomenon known as? What happens? What is the phenomenon known as? So what you can see is the milk curdles or changes to curd and or cheese, you can say curdles. What is this change known as? This is known as denaturation of protein. Denaturation of protein. So the globular protein becomes fibrous proteins. That's what happens here, denaturation. Now the third part is name the product of hydrolysis of sucrose. Is it a reducing sugar or a non-reducing sugar? So hydrolysis of sucrose. Sucrose is disaccharide. Okay, it changes to two monosaccharides. That is glucose plus fructose. Okay, so this is what happens. The answer is this. Now, is it a reducing sugar or a non-reducing sugar? Now, sucrose is a non-reducing sugar. That means it will not give silver mirror with tolerance reagent. No reaction happens like that, right? Going to the 15th question. An aqueous solution containing 12.5 grams of barium chloride in 1000 grams of water boils at 373.0834 K. Calculate the degree of dissociation of barium chloride. Okay, Kb for water is given. Molecular mass of barium chloride is also given. So let's see what happens here. So we have to find the degree of dissociation of barium chloride. Let's use the formula delta Tb is equal to I into Kb into M. Okay, so what is M? M is equal to, from this formula, so the W of BaCl2 divided by the M of BaCl2, molecular mass of BaCl2, into 1000, that is the weight of water given 1000 grams, divided by weight of water W of H2O. Okay, so let's substitute the values. We'll get M. So the weight of barium chloride here is 12.50 as given in the question. Now divided by the molecular mass of barium chloride is given here 208.34 into 1000 upon weight of water is 1000. Okay, so this term is gone. So what is M is equal to, you can calculate in your calculator. So what is coming is 0.059. So this is the value of M, the molality of the solution. Now I, what is the I? I is equal to, from the original formula we can take I is equal to delta TB divided by KB into M. Okay, that's equal to delta TB. We can find out from the temperature given here. Normal boiling point is 373 K. The difference is the I. So what is the value of I? 0.0834. Okay, 373.0834 minus 373. Okay, this is delta TB divided by KB for water is given 0.52 into M, the value of M that we have just found out, that is 0.059. So that's equal to, calculate. So let's take .718. So this is I, 2.718. Now let us see barium chloride, BaCl2 dissociates as Ba2 plus 2Cl minus. Okay, so we can put the value of this, can say 1 minus x here, and this will be x and this will be 2x. Okay, so dissociation, because of dissociation. So I is equal to 1 minus x plus 2x. So it is the total moles, that's equal to 2.718. So from this ratio we can find out x is equal to, what is x here? So this becomes 1 minus x and x, that is 1 plus 2x. So x is equal to 2.172 as 1. The value of x comes to be 0.86. Okay, 0.86. So in other words, we can say 86% dissociated. We actually say 85.9 is coming, so rounded off to 86. Right. You don't need to round off, you can just leave as it is. The 16th question. An organic compound C2H4O gives red precipitate when heated with Fehling solution. It also undergoes aldol condensation. Right? And in the presence of dilute NaOH. Identify the organic compound and write its IUPAC name. C2H4O gives red precipitate when heated with Fehling solution. The compound will be CH3CHO, that is acetaldehyde. Okay. The IUPAC name is ethanol. Is the IUPAC name. Okay. Now, which compound will be formed when this organic compound reacts with hydroxylamine? So, what will be there? It will form an oxime, that is acetaldoxime will be formed. So, which compound is formed? Acetaldoxime. We can write the reaction, but since they are not asking, we are not writing that. Then, third part. What is observed when the compound referred to in subpart 1 is heated with ammonical silver nitrate, that is this acetaldehyde heated with ammonical silver nitrate solution. What will you observe? You will get silver mirror on the base of the test tube. That is silver nitrate tolerance reagent it is. So, or you can say grayish white precipitate is formed. Grayish black precipitate formed along with the silver mirror deposition. So this is the most important part, the silver mirror is obtained. Okay, going to the next question, question number 17. Identify the compounds A, B and C in each of the following. The reactions are given. Ethanol reacting with PCl5 is there. So what is the product form? Compound A, what will be compound A? This, you know, ethanol reacts PCl5, we get C2H5Cl, otherwise called ethyl chloride. And what will be compound B? Compound B, because it is reacting with KCN, so you have C2H5Cn, otherwise called ethyl cyanide. Okay, and then we have it is reacting with hydrolysis, acid hydrolysis is happening. It is giving CH3COH and then reacts with ammonia and heat. So what will be compound C? Compound C will be C2H5CONH2. The amide will be formed, which will be otherwise called propanamide. Propanamide. Okay, so that is it. Now going to the next part. C6H5OH reacts with this zinc dust giving compound A. What is compound A? Compound A is C6H6 or otherwise called benzene. And then compound B, it reacts with methyl chloride and anhydrous aluminum chloride. B is produced, so B will be C6H5CH3. So alkylation is happening, so it is toluene. Okay, and what will be C? C, it is getting oxidized by acidified potassium dichromate, so CH3 group will be oxidized, so you get C6H5COOH, otherwise called benzoic acid. Okay, so that is question 17. Now the choice of this one, or give a chemical test to distinguish between the following pairs of compounds. Ethanol and methanol. So we can write ethanol reacts with iodine and NaOH to give pale yellow crystals of iodoform. Methanol does not. Okay, second is ethanol and ethanal. So we can write ethanal, just now only we have seen ethanal gives silver mirror with tolerance reagent. Otherwise ammonical silver nitrate solution. So while ethanol does not. Ethanal gives the test, ethanol does not. Okay, now third part is C, propane 2-ol and 2-methyl propane 2-ol. Now we can find propane 2-ol is CH3 CHOH CH3. Okay, now 2-methyl propane 2-ol is CH3 CH3 So one is a secondary alcohol, the other is a tertiary alcohol. So what you can write is 2-methyl propane toluol is a tertiary alcohol and reacts with anhydrous zinc chloride and corn HCl. So you can write 2-methyl propane toluol reacts with zinc chloride oblique corn HCl to form immediate cloudiness. Okay, while propane toluol produces cloudiness after 5 minutes because it is a secondary alcohol. So this way you can differentiate. You can go to the next part, that is question number 18 is a numerical problem. How to solve this problem, let's see. So part 1 and there is one more part. Okay, the rate constant of a reaction at 500K and 700K are given as 0.02 per second and 0.07 per second. So how we will solve this? Now what is there? Calculate the value of EA, activation energy, or energy of activation is what is asked here. So let's see how we can solve this. So first what we will do, we will use the equation, that is log K2 upon K1 is equal to EA upon 2.303 R into 1 upon T1 minus 1 upon T2. So this equation is used. So let us put the value, that is log of 0.07 upon 0.02. From the data we are taking 0.2 in this, right? It's equal to EA upon 2.303 into 8.314, that is the value of R, into 1 upon T1 500 and so we can solve it separately. 1 upon this, then we can take the LCM. It will come to be 700 into 500 and 700 minus 500. So this will come. Okay, substituting and solving. So what you will have, this can be solved using calculator. Log of this will be taken, going to be 0.544 is equal to EA upon 2.303 into 8.314 into 200, this is subtracted, upon 350000 zeros, right? So that is, we can change the subject now. EA is equal to multiply this, calculate in one step. EA is equal to, all these values come this side, 0.544 into, this will be reciprocated, 350000 upon 200 into 2.303 into 8.314. So the answer is coming to be 18228.079 joules. That is equal to 18.228 kilojoules. So this is the activation energy EA using the equation. Okay, going to the next part of this, that is second part. A radioactive substance which emits alpha particle follows first order reaction. Okay, first order kinetics is followed. Half-life period of this radioactive substance is 30 hours. Calculate the fraction in percent of the radioactive substance which remains after 90 hours. Okay, let's use the equation. K is equal to 0.693 upon T half-life. No? So that's equal to 0.693 divided by half-life is given as 30 hours is equal to 0.0 what will come? Okay, 231 per hour. So this is what is coming. So we can apply this on the equation, that is 0.0231 is equal to 2.303 upon 90 into log of 100 upon n. Okay, now from here we find out n. N is equal to, you can straight away use it in calculator of n, 2.303 is coming to be 12.5%. Okay, this will remain, right? So that is all in this video. So that is section C of the ISC 2024 paper. In the next video I'll deal with section D, the last part of this paper. Thank you for watching.